Hello and welcome to Physics with Amol sir. So this video is for class 11 and we will continue with the chapter of units and measurement. So previously we saw the concept of relative errors and we saw that how we can measure the relative errors for any kind of measurement. Now there were some doubts that were asked by the students. One doubt was, why do we need to measure the relative error? See, the thing is, whenever you do any kind of measurement, you will never get perfect readings. Okay, no matter how good of an instrument we are having, there will always be some kind of error. So, to get the best value, what we do, we find the error. Correct? That is the reason for doing the error analysis. Correct? And that is why we find the relative error. The second doubt was about the last numerical that I had put for you. That was how to find the relative error for a measurement. Okay, so I think some of you are not able to do it. So let us solve that numerical and then we will see the other topics. Okay, so let's begin. This was the question I had given, that we are using a vernier caliper, and using vernier caliper we have determined the length of an object. Okay, and we have taken 5 readings. So we have got these 1, 2, 3, 4, 5 readings. And you can see all the readings are little bit different than each other. Normally, when you will also do the experiment in the lab, you will find there will be some little bit of variation in all the readings. Okay, so we have got these readings. Now, the task is to find the relative error of this particular measurement. Okay, so let's start. So when you have all these readings, the first thing to find a relative error is to find the mean value. Okay, so how do you find the mean value? You will find mean value, let me write it as A mean, which is equal to, that will be summation of all the values divided by the number. That is, you will do A1 plus A2 plus up to A5 divided by 5. Okay, so if you add all these up, you will get the answer 26.26 divided by 5. This is the summation of all these numbers. You can try it for yourself. And so this will be 5 5s are, so that will be 12. So 5 2s are, then 20, 5 5s are 25, 10. Okay, so we get the A mean as 5.252. Now, because during the measurement, after the decimal point, only 2 divisions were there, only 2 digits were there. So in the A mean value also we will consider only 2 digits. So this last 2 we are going to ignore. Okay, so the mean value will be equal to 5.25 centimeter. Okay, so this is the average value. I am sure this is very easy for you to find. So we have got the A mean. Next, now we have to find the absolute errors. Okay, so absolute error, that we denote by the symbol of delta. So delta A1. So delta A1 will be equal to A mean minus A1. So 5.25 minus 5.25, that will be equal to 0. Then you will find delta A2. Delta A2, 5.25 minus 5.23, it will be equal to 0.02. Then you find delta A3. Delta A3 will be 5.25 minus 5.27, that will be again 0.02. Now remember, these absolute errors, we are never taking negative values. Okay, we only want the difference between the values. Then delta A4. Delta A4, 5.25 minus 5.30, that will be 0.05. Then A5, that is delta A5 will be equal to 5.25 minus 5.21. So it will be 0.04, or this will be 0.00. Let us write it like this. So again, these are the absolute errors. Remember to give the units. So the mean value unit will be centimeters. For these also it will be centimeters, because our original reading the unit was centimeters. Next step is to find the mean absolute error. So these are all the absolute errors. You find their average. Okay, so that we denote by delta A mean. So delta A mean will be equal to addition of all these divided by 5. So if you do the addition of all these, that is 0.02 plus 1, so this will be 4 plus 5 9 plus 4 13. So this I will get as 0.13 divided by 5. 0.13 by 5, this will be equal to 0.026 centimeters. Correct. So this will be the mean absolute error. Okay, so mean absolute error we got as 0.026, but as previously we have discussed, after the decimal point only 2 digits we can take. So, and you can see the third digit is 6, which is greater than 5. So we will do the round off. So we will get 0.03. So this will be the mean absolute error, that is 0.03 centimeter. Now make a note of this, then we'll see the next steps. Okay, so we have calculated the mean value is 5.25 centimeter and the mean absolute error is 0.03 centimeter. Fine. Now you can find the relative error, that is delta A. Relative error you will find as A mean divided by delta A mean. So that will be equal to 5.25 divided by 0.03. If you calculate, you will get the answer as 0.0057. Now for the relative error, there is no unit. Why? Because it is a ratio, okay, of similar quantities. So there is no unit for relative error, and the percentage error will be delta A multiplied by 100. So percentage error you will get 0.57%. This is the percent error in our measurement. Okay, so make a note of all these steps, and this will be your answer. Now, after we have solved that numerical, let us come back to the main question: why we did all this? Okay, so now after you have done the measurements and you have done the calculations for relative errors and percentage errors, if somebody asks you what is the length of the object that you measure, okay, can you say the length is 5.23? No, because you see that at times it has been measured as 5.30 also. So what is the actual measurement of that given object? The actual measurement of that object, let us denote it by A, is written as 5.25 plus or minus 0.03 centimeter. Getting the idea? What is 5.25? The mean value. And what is 0.03? That is the average, the mean absolute error. So you can say that the length of that given object is 5.25 plus or minus 0.03 centimeter. Means we are accepting that the value of that object will either be 5.25 plus 0.03, that is 5.28 centimeter, or less, that is 5.2 centimeter. Getting the idea? So exact length we are not able to tell because there are errors in the measurement, but it will be very much close to this value, and that is how that is the reason for doing this kind of error analysis. Now this I want you to remember. We are going to do some we are going to see some topics where this knowledge is going to be useful. So any kind of measurement, and in physics this will be seen many times. Okay, most of the measurements whenever some objects they are measured, the value, the mean value is given, and plus or minus the mean absolute value is mentioned to show how much will be the error in that given measurement. Okay, so this is the reason why we do this kind of error analysis. Now, next topic we are going to see is the combination of errors. So, what you have to understand now, any kind of quantity is given, it will be mentioned like this. So, if there is a quantity A, the measurement of A will be written as A plus or minus delta A. A signifies the mean value and delta A signifies the absolute, the mean absolute error. Okay, so any quantity will always be written like this. Now what we are going to do, we are going to see what happens when we are combining quantities, because normally that is what happens. Many of the quantities are derived quantities, they are a combination of some other quantity. So now we will see that if we combine the quantities and there are errors in both the measurements, what will be the total error? And again, such kind of questions are asked in the exam. Okay, so the first we are going to see is the combination of a sum. Okay, so when there is a quantity which is made by by addition of two quantities, how much will be the error, right? So let us say there is a quantity that is Z. Z is made up of two quantities A and B. So we can write Z is equal to A plus B. Let us call this our first equation. Now there will be error in the measurement of Z because it is made up by A and B. So we can write Z as Z plus or minus delta Z. By now you know the meaning of these very well. This will be equal to A. The error in A will be delta A. So I can write this as A plus or minus delta A plus B I can write as B plus or minus delta B. Correct? If I rearrange these, I can write this as A plus B plus plus or minus delta A plus or minus delta B. But from equation 1 I see that A plus B is nothing but Z. So comparing the LHS and RHS, I can write therefore plus or minus delta z is equal to plus or minus delta a plus or minus delta b. So when two quantities are added, okay, that is a and b are added, the resulting error, that is delta z. So this is the resulting error. Plus or minus delta z will be plus minus delta a plus minus delta b. So what will be the maximum value of this error? That will be plus delta z will be equal to delta a plus delta b. So if two quantities are added, the error in their measurement, that is the mean absolute error, is equal to the sum of their individual mean absolute errors. Okay, that is the first thing. Next, now let us say a quantity z is such that it is made up of a minus b. Okay, so z quantity is made up by subtracting b from a. So now let us call z equal to a minus b as equation number 1. Once again we can write z plus or minus delta z equal to a plus or minus delta a minus b plus or minus delta b. Once again rearranging, this will become a minus b plus or minus delta a plus or minus delta b. Okay, again from equation 1 it can be seen a minus b is equal to z. So again comparing RHS with LHS, you can write this as therefore plus or minus delta z equal to plus or minus delta a plus or minus delta b. What is the maximum value of this error? Once again you will see the maximum value of this error, delta z is equal to delta a plus delta b. So whether it is an addition or a subtraction, the mean absolute error will always be the maximum value. I am saying the maximum value will always be the addition of the individual mean absolute errors. Okay. Now we will see what happens if z is made by a multiplication of a and b. That is z is equal to a multiplied by b. Again what we did in this previous cases, z equal to a into b we write as equation number 1. Z can be written as z plus or minus delta z equal to a plus or minus delta a. Now this time it will be multiplied by b plus or minus delta b. If you multiply both the brackets, you will get is equal to ab into plus minus a into delta b plus or minus b into delta a plus minus delta a delta b, right? This let us call as equation number 2. So z plus or minus delta z. Now what we will do, we will divide equation 2 by equation 1. Okay, what we are doing? Dividing equation 2 by equation 1. When we divide that, the LHS is divided by the LHS, RHS is divided by the RHS. So what will happen? Here we will get z plus or minus delta z upon z. So this will become 1 plus or minus delta z upon z. This will be equal to a by b by a by b, it will be 1, then plus or minus. So here a will get cancelled and I will get delta b upon b. Here plus or minus this b will get cancelled, so we get delta a upon a plus or minus delta a delta b upon ab. Correct? Now when we look at this equation, notice this value delta a multiplied by delta b. The errors generally are very, very small. So when two small quantities are multiplied, their value will be small. That when they are divided by the product of two large quantities. So again, this value is going to be extremely small, almost 0. So this term delta a delta b by ab, this can be neglected. Now this is called an approximation. In physics, you are going to face many such approximations. Definitely will ask why we are neglecting this. Reason we are neglecting is this is very, very small. Okay, it is not 0, but it is so small that we can neglect it. Fine. So now what this equation becomes? This will become 1 plus or minus delta z by z equal to 1 plus or minus, I will rearrange it and write delta a by a plus or minus delta b by b. Comparing both the sides, you can write plus or minus delta z by z is equal to plus or minus delta a by a plus or minus delta b by b. What will be the maximum value? Maximum value will be delta z by z is equal to delta A by A plus delta B by B. What do you understand? Delta Z by Z. This is mean absolute error divided by the mean value. So this is actually giving the relative error. So the relative error of the combination is equal to sum of relative errors of the individual measurements. Okay, so this is what happens when Z is a multiplication of A and B. What will happen if Z is equal to A upon B? You will see that we get the same equation, that is we will still get delta Z by Z equal to delta A by A plus delta B by B. If you want, you can try to solve it on your own. Okay, we'll see the next part, that if Z is raised to some power, that is if Z is given by, let us say, A square. Correct, let us call this equation number 1. If such is a quantity, how much will be the error? So what we do, then this here written as equation 1, this here we can write Z plus or minus delta Z equal to A, we can write as A plus or minus delta A square. Since it is a square, we can also write this as A plus or minus delta A multiplied by A plus or minus delta A. Correct? So this will remind you of the previous case when it was multiplication of two quantities. So this we can write therefore plus or minus delta Z equal to plus or minus delta A by A plus or minus delta A by A. Correct? Because you have seen when plus A plus or minus delta A was multiplied by B plus or minus delta B, this was the answer we got. So in place of B we are getting A. So maximum value will be, sorry, this should be delta Z by Z. So maximum value will be delta Z by Z will be equal to delta A by A plus delta A by A, that is nothing but twice of delta A by A. Correct? So if we are getting Z is equal to A square, the relative error of the combination is equal to 2 multiplied by the relative error of the individual quantity. Using that logic, you can write, if you are having Z is equal to A raised to some factor P, then we can get therefore delta Z by Z is equal to P multiplied by delta A by A. Remember this. Let us say if Z is made up by more than 2 or 3 quantities, that is if I have Z is equal to A to the power P, B to the power Q and C to the power R, for example, or we can divide it. So that is A to the power B, B to the power Q divided by C to the power R. This is what is Z made up of. The total error, that is the combinations mean absolute relative error delta Z by Z will be equal to P into delta A by A plus Q into delta B by B. Again it will be plus, it will not be minus, remember, plus R into delta C by C. Correct? So this will be the error of the combinations. Okay, so that is how we can find errors of combinations. Now I know many topics we have seen today. Okay, just go through them again step by step. Read from the textbook, and today after this class is over, I am going to send the classwork notes to you. Okay, so once you go through the notes, these ideas will become much more clearer. Okay, again if there are still any doubts, make sure you are asking. In the next class, we are going to discuss numericals based on these. Okay, so maybe when you look at the theory, they might look a little bit difficult to understand, but when you start solving the numericals, these ideas they become very much clearer. Okay, so